Hello. This video is going to be a bit of an introduction to binary, to decimal conversion and decimal to binary conversion. One of the basics of IP addressing, you need to know it. Generally we live in a decimal world here, so we live with those sorts of numbers, so 135, 145, 192. Computers work with zeros and ones. So they've just got two states, they're either on, could be a 1, or off, which is a 0. So what we're going to do is just have a look at how to convert decimal to binary and binary to decimal. And it's something you need to get quite good at, because later on we're actually going to start combining two different values. This is an IP address over here, so it's a common one. 190.168.10.1 is an IP address. It's an address we'll give a computer on layer 3, and it will have a subnet mask, and in this case the subnet mask I've given it is a C-class subnet mask. It is a fully classful address, and that's also in decimal, written in decimal for us, but the computer needs to convert it into binary. So those two addresses combined actually give us our network number. Just for your information at the moment, although we won't be doing it, they both use an AND function with different inputs, and they'll get a particular output, but that's a different video. Okay, so what I've got here is a bit of a scale up the top. I've got my decimal values here, and I've got a little calculator down here and some numbers to play with as we go through, and we can work them out. So generally binary comes in 8 bits. 8 different values are given to us, and if you start from the least significant bit on the right, we give that value number 1, and every next value across as a decimal value is double the previous value, just for 8 bits though. So there's 8 different values there, and later on we'll add them all together down here to give ourselves different values, but what we're doing is representing in binary different things, different values, different decimal values actually have. So let's hop into it and start working out these decimal conversions, and then we'll work on the easier one, and actually is to convert binary to decimal. Okay, so if I'm going to represent the value which is decimal 1 on this scale, for those of you who are on top of it, we have 1, 1. We've got no 2's in this value. We've got no 4's. We've got no 8's. We've got no 16's, no 32's, no 64's, and no 128's. So what we're saying right across there, that this decimal value has 1, 1. And that makes sense, doesn't it? So that's good. Let's have a look at the value 3. So if I put those two values in, what I'm going to do is add a 2 and a 1 together, and that will equal our 3. So there'll be no 4's, no 8's, no 16's, no 32's, no 64's, no 128's. So at the moment with small numbers it's a bit easy to work with. For longer numbers down here we'll actually work a little bit differently. So the value 5, we can have a look at it, and you can say, well, let's actually go the proper way. So can 128 fit into 5? Well, no, it can't. Can 64 fit into 5? No, it can't. So there's none of them. Can 32 fit into 5? No. 16 fit into 5? No. 8 fit into 5? No. Can 4 fit into 5? Well, yes, it can. So there's going to be one value in this column. Now the remainder, so 5 minus 4, the remainder is actually going to equal 1. So that's the remainder that we have to play with here. So can 2 fit into 1? No. Can 1 fit into 1? Yes, and it fits in 1 time. So now we've got nothing left. So that's the long way of doing it. We start on the left hand side with the most significant bit because it's got the biggest value, and we work our way down across this system and try and get the biggest bit into these values. Now you can never end up with an error in there because 2 plus 1 equals 3, so 3 plus 1 equals 4. So if you had 1, 1 there, if you did a bit of binary maths, for 3 plus 1, it'll actually equal just a single 4. So you can never get into trouble using this long division process if you've understood it. So it's something that needs to be worked on and get really comfortable with. So let's do the last two here. So 145. So let's do this long division. So can 128 fit into 145? Well, yes it can. It'll fit once. So let's just put it here. So I'll put an equals in this now. So 145 minus 128 equals 17 is the remainder. So will 64 fit into 17? No, it won't. Will 32 fit into 17? No, it won't. Will 16 fit into 17? Yes, it will. So let's change our calculation. So let's minus 16 in that. And our remainder is now 1. Can 8 fit into 1? No. Can 4 fit into 1? No. Can 2? No. 1? Yes. So 145 equals that value in binary. So that's okay. So our remainder is 0. 192, let's look at that. So equals 192 minus 128 is the first one. So can 128 fit into 192? Yes, we said it can. Oops, get out of that. So let's put a 1 there. So 128 fits into 192. The remainder is 64. So can 64 fit into 64? Yes, it can. And take the 64 off, and our remainder is 0. So everything else in there is 0. And you have to put them in. You can't leave them dangling in the breeze. With an 8-bit number, this first one is 0, 0, 0, 0, 0, 0, 0, 1. Let's go for this one here. This 145 in decimal in binary is 1, 0, 0, 1, 0, 0, 0, 1. And 192 equals 1, 1, 0, 0, 0, 0, 0, 0. In computer world, we're expecting an 8-bit number, so we have to put all the bits in there because they all have some value that we need to play with. So that's a very quick idea of how we convert a decimal number into a binary number, and it's something that you will need to get good at. So we'll give you a we should get you a bunch of samples to play with, or you can go online and there's a lot of them. Okay, so the next one is to convert an existing binary number into a decimal number. And I think you've probably guessed it already, but it's going to be quite simple. We're not going to add any of the zeros up. We're going to add the values that have a 1 on them. So let's have a look at that. There's 1, 8, 1, 2, and 1, 1. So that equals 8 plus 2 plus 1 equals 11. And that makes sense. So 8 plus 2 equals 10, plus 1, our value is 11. I should have put that value in there, shouldn't I? Okay, so let's have a look at this number here. Now, there's actually two ways of working this out. But let's go through the long way. So that's going to equal, so there's 128 over there. So 128 plus is 164 plus there's 132 plus there's 116 plus there's an 8 plus that. There's no 4. There's a 2 and a 1. So 2 plus 1 that value there equals 251 in decimal. So we've converted that binary to that decimal value. So again, computers use zeros and ones. We use these because we're used to them. We can remember them better. Okay, there's another way of actually working this out, and I'll come back to it after we've done this number, because you can see there's only 1 bit difference between the two. So let's work out this number at the end. So we'll go through these next two and see how we go from there. The next three actually. So let's have a look at this one. So yeah, we've got 164, 16 and 8, 4, 2 and no ones. Okay, so let's chuck that in. So there's a 64, 16, 8, where are we, 4 and 2, and that equals 94. That looks about right. So 64 plus 16, if you want to do it in your head, I always double check. So 64 plus 16 is going to equal 80, plus 8 is 88, plus 2 is 92, plus 2, plus 4 is 92, plus 2 is 94, so that's correct. Let's have a look at this guy down here. So we're starting with 16. Let's put this one up here. So this lot equals 16 plus 8 plus 4 plus 2 plus 1, and that equals 31. The next number below it equals, so 64, 32, 16, 8, 4, 2, 1. So let's work our way down that. So 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, 127. These two have special stuff, so let's come back to those as well. So we'll come back to this number, come back, and we'll also come back to that one and that one once we finish this lot off. Okay, so this one is relatively special because most of our subnet masks are actually built up of that value there. If we add them all together, let's go through it, we should end up with 255. So equals 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And I put a 129 in there, didn't I? That's very good. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. And that tells us that there's actually 256 different values in this numbering scheme. And that it'll go from, if we just change this one up here, it'll go from 0, so all zeros, down to all ones. And that equals 256 different values that we can have in an 8-bit number. So, handy thing to remember. The 255, also handy to remember because it means it's all ones in that 8-bit number. So if we look at this value here, now this is an IP address, and this is the subnet mask. The subnet mask implies 8 ones in a row there, separated, another 8 ones, and another 8 ones. And as far as the computer sees it, there's 24 ones in a row. So let's go back to these. Well, we'll come back to this value because we're still working stuff out, and then I'll come back to those two at the end. So let's have a look at this 251. 251, if we look at it a bit differently, is 255, it's that value minus the 4. So if I just, I'll put the calculation down here, it equals 255 minus the bit that we don't have, which is the 4 value bit. And there it is, equals 251. So it's another way of working out your values. Like this one down here, there's only one bit that doesn't have a value. So we could say there equals 255 minus 128. And that equals 127, which is what we worked out before. So that's pretty good. Okay, so we don't need to come back to that one anymore. Let's have a look at these two down here. There's another way of working these out. They're all ones and then all zeros. And this one, all ones and all zeros. What that actually means is that that value there is actually going to be one less than the next bit along. So let's put this in slightly differently. So let's grab our all zeros up here. And let's work our way down. We'll just shove them all in. And we'll put a 1 in there. And then a 1 and a 1. And then a 1 and a 1 and a 1. Oops, I missed that one there. Let's just keep going. So all I'm doing is filling up from the right hand side. Probably a quicker way of doing this, isn't it? So let's have a look at it. So that's, we know, is 0. This one, if we use my thinking at the moment, which I haven't actually said, but anyway, this value is going to be 1 less than that value, which is 1. This one will fill up, which means it's 1 less than that value, which is 3. Oops. This one will be 1 less than that, which is 7. This one is going to be 1 less than the next, like that 0 bit, so 16. It's not 16, it's 1 less. This one is 1 less than 32, so it's 31. This one is 1 less than 64, so it's 63. And this one is 1 less, which is the same value we had there, which is 127. And we do use these values, so it's handy to remember that one. Okay, so that's about it really. I think we've done everything I needed to do there. So practice this stuff, practice converting decimal to binary, and then binary to decimal as well, and really get used to it, get quite comfortable, and everything will be good. Thank you for listening. Cheers.